In this problem, we're going to solve the Tower of Hanoi. And the Tower of Hanoi is a puzzle that involves moving these disks of the tower one at a time in the following fashion. You can't move a disk that is larger on top of a disk that is smaller. So this right here would be an illegal move. And the end goal is to get the entire tower onto the end pole here. So we have 3 poles. This is the start. This is a temporary pole that we're allowed to use, and this is the end pole. So we want to move the tower from the start here to the end. And this is a problem that can be solved recursively. And it's a recursive problem because at every step of the way you have to solve a subproblem. And I'll explain what this means in a second by example. So the end goal, right, is to move the entire tower over to here. Well, in order to do that, we're gonna have to get this largest disk over to the other side without anything on top of it. So we need to somehow be able to get this guy all the way over here like this. That's the first goal. Well, in order to do that, that means that we have to free it up to move over there. And that means that we have to get everything on top of it onto this temporary pole. Okay, so once we get everything onto this temporary pole, then we should be able to move this guy over here. And then once that happens, then the problem becomes, how do we move all 3 of these disks over to this one? And that should complete the problem. Okay, so this problem sets itself up perfectly to be solved in a recursive manner. And the recursive problem here is, how do we get these 3 disks over to this temporary pole so that we are then able to move the largest one over to the end pole? And so this is a subproblem, right? These 3 disks here are a tower of size 3. So it's a tower of, size, whatever the original tower was, -1. This is a tower size 4, and we're looking to move a tower size 3 over here. So we can do this in a recursive manner, right? Where the solved towers is going to be on a tower of size num disks -1, and we know that the start is going to be, this tower 1 here, and then we're going to be using the end pole here as a temporary one, because in this scenario, our goal is not to move all of these over to the end, it's to move them to the temporary. So the temp becomes the end, and the end is going to be used as the temporary. So our solve towers 4 calls solve towers on a tower of size 3 where the start is 1, and we are using the 3rd pole as the temporary, right? And the 2nd pole is the end. That's where we want to move them. So let's just assume that that works, all right? We're able to do that. Now, in the solve towers 4, this is the original call to this function, we move the disk from the start to the end, right? Now that we freed it up, we're able to move it to our destination. All right, now this is done. Now what we have to do is solve the subproblem of a tower of size 3 just one more time, except this time we're moving it from the original temporary pole over to the end pole, and we're using the start as the temporary. So using this as the temporary, we want to move a tower of size 3 from the original temporary over to the end. So you can see here we solve towers with num disks -1, so tower of size 3. We're moving it from the temp to the end. And we're using the start as the temporary, so let's just assume that that works. Now we have tower solved. So given that recursive logic, you can imagine that we can solve a tower of any size, and it'll keep recursing and creating subproblems in the same manner. So I want to walk through the recursive algorithm here and how we, go all the way down to the base case and the logic behind it. So let's start off by calling solve towers on the entire tower of size 4. All right, so we call solve towers size 4, and we're going to start by using the first pole as the start. We're going to be using the second pole as the temporary pole, and we're going to be using the third pole as the end. All right, so we make this call, and the first step of this is, all right, num disks is not equal to 1, so we're gonna call solve towers on num disks -1. So we're gonna call this on a subproblem. We're gonna break this into a subproblem. We're solve towers on a tower of size 3, and we want to move the tower from the start, so that's 1 here, right? And then we want to move it to whatever the temporary of this, call on the fourth one is. So we're gonna move to the second. We want to move this third one to the second there. And we're going to be using the third pole as the temporary, right? So when we make this call right here, we need to solve a new problem. In order to move the tower of size 3 over to this pole, that means we need to clear the room for this guy to be moved over here. And in order to do that, we need to get this tower of size 2 out of the way. We need to move this, over to the third pole. And then once that is done, then we can move this one here. So it becomes a new subproblem. When we call solve towers of 3, now we have to call solve towers of 2, right? So this one is calling solve towers of 2, and the goal is to move from whatever the start is. So the start is here, and we want to move it to whatever the temp is of the one that called it. So this is 3, so we want to move this one to pole 3, and we're using whatever that one's end is as the temporary. So solve towers on size 3 is using this one as the temporary. So we use that. Sorry, this is the end. But in order to move these guys all the way over here, the first step would be to get this one over here, but we can't do that yet because this one is on top of it. So again, it's a new subproblem. How do we get a tower of size 1 over here so that we can move this one over here. So then we call solve towers 1, that's solve towers 2 calling this. How do we move a tower of size 1 over to the second pole using this one as a temporary? All right, well, this is where the base case comes into play. This is the base case. And the reason that this is a base case is because in order to move a tower of size 1 to its destination, whatever that may be, we don't need to solve any other subproblem because there's nothing on top of it preventing us from moving it. So we don't need to solve any subproblems. We can just move the disk from the start to the end. There's nothing stopping us. So why don't we do that, all right? We reach the base case right here, and so we can move from tower 1 to tower 2. All right, done. So that was finishing this call in the solve towers 2 call. And so once that finishes, now we can move on to this step where we move the disk from the start to the end. All right, so we move this disk from 1 to 3. Okay, and now we go to this statement where solving the subproblem of moving num disks minus 1 from the temporary to the end. Okay, what is the temporary? It's from pole 2. This is the temporary, and we're moving that one to the end, which is the 3, right? And so this is, again, the base case because it's a disk of size 1, so now we can do that. Okay, great. Now, solve towers 2 finishes. And now we're back to this step in the solve towers 3 because solve towers 2 finished. So now we're here. Move disk from start to the end, okay? So the start is 1 and the end is 2. So now we finally cleared the room, right, to move this one here. Okay, great. And now it's the subproblem of how do we move these two back over here. So now we're gonna solve towers on numDisk minus 1, and we're going to try to move them from whatever solve towers 3, whatever that temporary is, we're going to move it to the end, which is the 2. So we're moving from 3 to 2. And so we've already seen how these kind of play out. So once that finishes, it's going to be like that. And now, solve towers 3 just finished, right? And since that just finished, now solve towers 4 is going to be onto this step where we move from the start to the end. And now we have the problem of moving solve towers 3 from whatever solve towers 4 temporary is over to the end. So how do we get from 2 to 3? Using 1 as the temporary, right? We're using the start as the temporary here in this function call. And so we've seen this work, and so once that finishes, then we'll be over here. And that's when solve towers 4 finally finishes and we're done. And the problem has been solved recursively.